Hello everyone, I welcome you all to grade 10 mathematics. This is an exam type question for grade 10s as far as functions are concerned. So the purpose of this video is to actually interpret, the information that we are given before we can even solve the questions that follow or what we are required to find or determine, right? So the sketch below shows f and g. So f and g are obviously functions or graphs, right? The graphs of f of x is equals to 1 divided by x minus 1. Let's write that down. F of x is equals to 1 divided by x minus 1. Now, what type of a function is this? This is a hyperbolic function. Hyperbolic function. Another question is, what do you know about a hyperbolic function? It has got a form of, let's say f of x. You can also have g of x and h of x, or y is equals to something. F of x is equals to a divided by x minus p plus q. So you know that a hyperbola has got this form. And a here determines whether the hyperbola is going to be on the first quadrant and the third quadrant if a is positive, or the hyperbola can be on the second quadrant and the fourth quadrant if a is negative, right? So before you can even look at these, these are some of the things that you can just appreciate about the function that you have, right? Okay, so what else do you know about a hyperbola? A hyperbola has got things that we call asymptotes. Now, asymptotes, my younger brother would call them imaginary lines that a function approaches but never touches. So basically, if you've got a function like this, x minus p is equals to 0. If you solve for x here, as you can see, this is the denominator of this portion. X is equals to p. So this is an asymptote. But what type of asymptote? It's a vertical asymptote. Right? So it's a vertical asymptote. It goes up, down, right? And then what is the y asymptote? It is y is equals to q, right? And then this now is the horizontal asymptote. Okay, perfect. So now, if you can see here, if you are given a function in this manner, and you are supposed to, break it down. First of all, your a is positive there, which is 1. So your function should be on the first quadrant and the fourth quadrant, as we can see from here, right? So now, what are the asymptotes of this function based on what we are given there? So let me just use another color for this. So the asymptotes, let's start with the y asymptote. Y is equals to negative 1, right? So there should be a line that is horizontal, that is like this. They normally write it as a dotted line, This is the y asymptote, the horizontal asymptote of this function, right? What about the x asymptote? So now at x, it's like we can have here a plus 0, right? But we do not normally write it. So x is equals to 0. This is your vertical asymptote. So this is the first thing that we have identified about our function, that it has got asymptotes at negative 1 and at y is equals to negative 1 and x is equals to 0, right? That is what we know about a hyperbola. And also our a here is 1, so our a is positive, so our function should be on the first quadrant and the third quadrant, of which is the case, right? What else can we take note here? A hyperbola, as you guys might remember, A hyperbola has got axis of symmetry. It actually has got two axes of symmetry. It has got this one. Its gradient is positive 1 all the time, guys. And it has got another axis of symmetry line. This one's gradient is negative 1, right? So for a hyperbolic function, you will always have axis of symmetry, right? Perhaps, you might have not been taught about this yet, but it's okay. I'll just leave it there. Okay, let's continue. Let's look at the other function that we have. We have got g of x, which equals to ax plus q. Let's write that down. So g of x is equals to ax plus q. What type of a function is this? This is a linear function. Or you can just say a straight line. It's a straight line graph or a linear function. Whichever, way is going to assist you to, to be joyous, whatever. Okay, so now, this is a linear function. A linear function has got a form of g of x, or let me rather, use what you guys are used to. Let me use y is equals to mx plus c, right? You guys are used to this form, where m here, m is the gradient of the line. M is the gradient, so this is going to be the change in the y divided by the change in the x, right? So m is basically the gradient of the line. It just determines as to whether the line is steeper or the line is gentle. It determines that. And then now, c here, okay, so in our case, m, which is the gradient, will equals to this a that is here. You see? Do you see the link? And then now this c here, this c is the y-intercept. Now you might be asking yourself as to what in the world is the y-intercept? Remember, we have got the y-axis line, which is like this. So you will have, wherever this line is crossed, at this point is going to have a y value, and the y value there is going to be c. So c is the y-intercept of the line. So you're expecting a straight line graph and a hyperbola, right? All right, people. So now we are going to continue interpreting the text that we are given. Okay, so it says points A and B, this A and B, lie on the graph of G. Now G is the straight line graph here, and as you can see, there is point A and there is point B over there. So the two graphs intersect at C and D. So intersect simply means that they cross or they touch at that point, So you see, there is point C, the graphs are crossing there, and then there is point D, the two graphs are crossing there, okay? And then the line BE is drawn parallel to the y-axis, right? So what does that mean? This is the line BE over here, BE. So if it is parallel to the y-axis, what do we know about the y-axis? The y-axis is a vertical line, right? So basically it means that the gradient of BE and the gradient of the y-axis are exactly the same. Fortunately or unfortunately, in our case, I want you guys to go and find out as to what is the gradient of a vertical line. All right? Okay, cool. So now that you have read the info that you have been given and you have connected the dots, it's time to solve the question.